So there are multiple machine learning algorithms that are being used and developed in industry each day, but there's one class of algorithm that is most highly used in industry when it comes to actual use cases, and that particular class is ensemble models. And in this video we'll look into that. Hey everyone, my name is Shubhankit, and in this video we will look into ensemble models, and this will be part 1 of the video where we'll look into the idea of ensemble models and we'll talk about bagging algorithms. This is your real data science channel, and in this channel we talk about more generalistic approach to our data science. As we want our model to become more generalistic, we want our approach to become more generalistic as well. So talking about ensemble models, it's a quite beautiful theory of ensemble models of how how to use that particular category of ensemble models. And as I said in the intro of this video, that ensemble models are the one which are most highly used in industry, right? So you anyway have to have a knowledge of that. When you will be doing your projects, you will be getting your best results on ensemble models. When you will be doing your industry work, actually when you will be working as a data scientist or a data analyst, in that case also you will be using most time ensemble models when you will be working on a real world solution. So that's why it's important to understand, and as I said, the theory is beautiful there. So let's not waste much time and let's dive directly to the video. So let's dive into the video, guys, and the first thing we'll talk about is the general idea of what are weak learners, why do we need a weak learners, why do we need an ensemble model, right? So and what are ensemble models, everything would be covered, and as you can see on screen, right? So we will be following this outline, right, in the video, that we will cover the idea of weak learner, the idea of generalization, then the class of ensemble models, the category of ensemble models. There are multiple types of ensemble models based on their structure, and then we'll talk about the first kind of ensemble models, that are bagging models, right? And then we take one example of a bagging model, that will be your random forest. So and there's no code, guys, here. There's no code. Just sit back and watch the video. You can make notes. Notes would be handy for you. But whatever would be asked in a data science interview from a bagging model point of view, or in general the basic idea of random models, or ensemble models point of view, that will be covered in this video, and that I can guarantee you. So yeah, let's start. So firstly, what is the idea of weak learners? So the problem that we face in our general machine learning algorithms is that they overfit. Okay, so just giving you a little bit of brief idea, that when you have a machine learning model, you try to increase the complexity of that machine learning model to fit that model better on the training data set, right? So what you want, okay, my model should perform better on the training data set, right? So for that you increase the complexity of a model, and this increase in complexity, this results in increase in variance. In general idea, what is variance? Variance is a measure of spread, right? So variance increase in a model means that when you are testing out this model, you are getting varied results. You are not necessarily getting wrong results, right? Getting higher variance cannot relate directly to getting higher error, although it will be same, but getting higher variance means that you are getting quite positive error in one case, quite negative error in one case, like that, right? So it varied error. What you want your model to be more generalized. So as I said, we want our model to be more generalized. We want to remove this overfitting case, right? And what was the reason of this overfitting? You are increasing the complexity of your model. Okay, you are increasing the complexity of your model. So when I say you are increasing your complexity of a model and it is leading to overfitting, so that means that your model is memorizing stuff, right? It is memorizing the pattern instead of generalizing the pattern. What we want our machine learning algorithm is to generalize the patterns of your data and then make a decision out of it, because then that will be an actual machine learning algorithm, right? Otherwise your model would be just prone to overfit each time. So this memorization is a problem here when you increase the complexity of your model, or when you use a highly specialized model. So the solution to this is weak learners, right? Weak learners is, you can say, models that are little bit better than the basic model. When I say basic model, I am calling it a random model, right? Basically, if you are choosing something, let's say that particular model has 50% accuracy, so your weak learner would have just slightly better accuracy than your basic model, right? Let's say a model with an accuracy of 70%, okay, and you use this model to make your decision, right? And then the idea is that you don't use one weak learner, you use multiple weak learners, multiple weak learners, right? So instead of using one weak learner, you use multiple weak learners to make your decision, right? So the point is that instead of using one specialist model, okay, specialist model, we use multiple generalistic model. And the logic behind this is that there would be some pattern that will be hidden in the other data, and that will be covered in the multiple models, right? So the idea is that let's say your data, you had let's say in your data you had 100 rows, okay? So for the training of this specialist model, you use these 100 rows of data, and you like you use, let's say, 80 data and let's 20 test or 20 went for testing and like that. But when you go for a generalistic model, it might not be able to cover all the trend on the 80 data set. So in this 80 rows, I divide into 80-20. 80 goes to my training data, 20 goes to my test data, right? And this training data goes to one specialist model, and it detects whatever it can from it, and it does that. Now this training data will go in parts. To our generalistic models, right? And let's say I'm using 100 generalistic model, 100 weak learners, right? 100 weak learners. So all in all, when they'll come together, they will cover all the pattern of the data, and they will reduce the variance for your machine learning model, because now you have covered all the pattern. See, variance comes up only because you are focusing on one specific insight from your data, right? You are missing some insights from your data, and that insight is being occurred in the test data. That's why you are faulting on the test data. That is the idea of variance, right? So same thing will happen here, is that if you have 100 weak learners, they will cover some part of your insights, some parts of your data, some pattern of your data. Each of them will cover some pattern of data, and we will assume, or we are hoping this, that none of the pattern will be left, and the final model will learn everything that is possible out of the data, right? So that is an idea. It logically sometimes it seems a little bit vague that instead of one specialist model you are using 100 weak models, but the idea is is same, right? It's kind of a wisdom of crowd kind of a thing. Let's take one more analogy to understand this, right? So if right, when you if somebody of you have gone to court or something, right, court or to and have seen a justice bench basically a group of judges who makes any decision, right? So for example, for any decision, let's say there's a person who has committed a crime, right? This person has committed a crime, and now there are 4 judges out there, right? So that is an idea, right? All of these judges, although they are knowledgeable enough to give a decision, still we use 4 judges here to take a combined decision of those judges, right? Okay, what should be the punishment for this particular person? And the reason for this is, let's say this particular person is from a particular state or particular ethnicity, right, or a particular religion, and this particular judge is of a same state and of a same religion, right? So he might have some sympathy with this person, right? And let's say this person is of a opposite state, that state that has a rivalry with the other state, something like that, right? So he will have some hatred toward this person, right? So they all have their own biases, right? So they all have their own biases. Okay, this judge will want to give a less punishment to this person, and this judge will want to give a harsh punishment to this person. And the idea is that when we'll take a collective judgment, of all those 4 judges for this particular crime, it will you can say it will balance out. You will get a more generalized and the ideal punishment that this person should get, right? So that is an idea. That's same idea that we use for random models. Same idea that we use for ensemble model. Instead of using one model, you use multiple weak models and then make the judgment. Okay, that is a simple idea of ensemble models and the idea of generalization. Now let's talk about category of ensemble models, right? Again, a beautiful topic. So when we talk about ensemble models, it basically means that you are using group of models. Now how you are using those group of models, it can be two ways, right? Two ways, and then it can be divided into three categories. So two ways would be you either use them in parallel or you use them in series. Okay, parallel would be that you have, let's say these are my three models that I am using, M1, M2, M1, M2, M3, right? So I will use them in parallel. Basically what I'll do, I'll have my data, I'll give some part of my data to all these three models, and then I will use their collective judgment and they'll take a majority out of it. Let's say this is a classification problem. So my model 1 gives me 0, model 2 gives me 0, model 3 gives me 1. So my final output would be 0 based on the majority, right? This is a basic idea of parallel models, right? Parallel ensemble models, that you have models in parallel, they all give an output, you take a majority out of it. In case of series, what happens, and this we'll in detail see in the next part of the video, so do subscribe to see that. So in case of series, what we do, we take machine learning models in sequence, right? We take machine learning models in sequence, right? So what will happen now, that once you have taken the machine learning model in sequence, this model will work on the errors of this model, right? So let's say this is M2 and this is M1. So M2 will work on error of M1. Similarly, M3 will work on the error of M2, right? They keep improving on each other, right? These are called boosting models. You're basically boosting your algorithm, over each step. You're just working on the points that have shown errors. That we will see this in detail in the next part. But for parallel, we have seen that okay, you have models in parallel. Your models arranged in a parallel structure. They all give you an output. You take a majority out of it. In case of classification, you take a majority. In case of regression, where your output would be a continuous variable, in that case you will be taking measure of central tendency, right? So you will be taking either mean, median or mode, right? Not mode, sorry, mean or median, right? So yeah, that will be the idea of parallel or series model. So now if we classify it properly, just to see how many ensemble models are there, what kind of ensemble models are there, right? So you do it like this. You have ensemble models. So you have three basic types of ensemble models. Okay, first of them is bagging, right? These are your parallel ensemble models. They are called bagging models. Then you have boosting. These are your series models. And then you have stacking. These are also parallel model but with some modification. This we will see in the part 3 of this series, right? So do subscribe to this, guys. I'm emphasizing on that because ensemble models are really important from an interview point of view, from a job point of view, and from actual working point of view. So this will come in 3 parts where we will see each of them. So and this part we are covering bagging. So let's talk about bagging. Okay, for this part we'll talk about bagging. So bagging are ensemble models where the models are arranged in a parallel process, and one idea of bagging model is bootstrap sampling that you need to know. Okay, bootstrap sampling. Okay, so if you remember, I said okay, you have a data here. This is your complete data. This is your complete data, right? And then you have your machine learning models. And as of now, they're untrained machine learning models, right? So let's say M1, this is M2, this is M3, this is M4, and this is M5. Okay. So this data would be split, right? This data would be split into all of these models. Okay. And the training will happen on this particular splitted data, right? For example, let's say D1 is going into M1, D2 is going into M2, D3 is going into M3, like that, right? So D1 data would be used for training of M1, and then it will give result for any test data, like that. Okay. So now how does this split happen? Okay, how does this D1, D2, D3, that particular split is happening? That split is happening by the use of bootstrap sampling. Bootstrap sampling is nothing but you can say random sampling with replacement. Okay, basically it looks like this. Okay, let's see what bootstrap sampling is in detail, right? Because this is important. So bootstrap sampling, so let's say you have a list of numbers. Okay, you have a list of numbers and these are 1, 5, 19, 16, 87, right? And I want you to pick a sample of 3. Okay, sample of 3 from this, and let's say you randomly pick it. So you have 1, 5 and 16 here, right? Next time you pick a random sample, so we said sampling with replacement, right? So when I picked 1 from this list, let's say this list was A and this list was P and Q, so I'm picking random samples from A into P and Q. Okay, so when I selected 1, 5, 16 from A, next time when I select Q, I have all the values available in the A. Why? Because sampling happened via replacement. Sampling happened with replacement, right? That is an idea. That is an idea of bootstrap sampling. Okay, when I picked 1, 5, 16, it's not like now they are removed from the sample. They are still in the list A, and when I pick Q, I can still pick 1, 5, 16. So let's say randomly I pick and I got 1, 19 and 87. So see, 1 has been picked again. Similarly, next time I pick, I can pick up 19, 16 and 87. So this time 19 and 87 are picked again, right? So that is the idea of bootstrap sampling. So what happens here in bootstrap sampling, that you create bootstrap sample of your data and you pass them in your machine learning models and they get trained over that, right? So M1, M2, M3, M4, all of them will get trained over D1, D2, D3 like that. Okay, simple bootstrap sampling. So once this sampling happens, your model are getting trained on these samples, right? Your model get trained on this sample, and after that any new data will come up. It will just take opinion of each particular model. Let's say you are doing a classification problem, all of them give 0, answer would be 0. All of them, let's say, give 1, so answer would be 1. Let's say 2 of them give 0, 3 of them give 1, so answer would be 1, right? Based on majority. Simply simple. If this is a regression problem where output is a continuous variable, then you will be taking mean or median of that particular outputs, right? So this is your general idea of bagging models. To be honest, this is all you want to know for a basic idea of ensemble models. Now let's talk about one example of so there's one more point that you need to remember, that when it comes to bagging models, these M1, M2, M3, M4 all will be of a same type. When I say same type, it means that they would be same type of models, right? Either they would be all decision tree or they could be all logistic regression, like that. Okay, now when all of them are decision tree, in that case it is called random forest, right? And it makes sense, right? Multiple forests, multiple trees makes a forest. Okay, so what happens in random forest is that all of your these models, these individual models, they are decision tree in themselves, right? dt1, let's say dt2 and dt3, dt4, right? And all of them are weak learners, right? So all of them are weak learners, and weak learners in case of decision tree would means that all of them are they are having less branches, right? So if you just imagine a structure of decision tree, you know that as the depth of decision tree increases, its complexity increases. So all of them would have a limited number of branches in their decision tree, right? That is why they are weak learners, right? And just like we are splitting up the data by bootstrap sampling, right? You also select features, right? You also select features as well, right? For example, if you are having let's say this was, let's say, your data that has been split, and that, let's say, you had 12 features in your data, right? And you will pass a parameters. When you if you will see a code of this, you will understand. Okay, so if I have 12 features, I have an option to pass how many features I have to give to each particular model, right? So let's say I pass as that particular thing as 6, right? So for each particular decision tree, 6 random features will be selected and they will be passed here in the decision tree. So you understand how the data is different in each particular model, and understand what advantage it will have. Let's say there's a particular feature F3 in our data, and this F3 feature is getting really high weightage in training. It's like a really important feature. But there is also a feature of F8, and because F3 gets that much of importance, the idea of F8 is, the idea of F8 is getting reduced. Whatever contribution F8 was bringing is getting ignored, or is not getting that much of a weight in my decision tree models, right? So what will happen in this case, that in some models, when you randomly select the features in some model, let's say in D2, second decision tree, what will happen, that it might happen that feature 3 is not occurring here. Feature 3 is not a part of the data on which D2 is trained, right? So what will happen in this case, F8 will get the weightage that it wanted, right? So when we will actually test out this model, this particular mistake would be corrected, that okay, there was some insights in F8 feature which was we were not able to get, but here, because F3 is ignored in the second decision tree, so F8 will get equal weightage. So the output, if it is getting varied by the use of F8, it will not get varied now, because this decision tree will give the right output that it is supposed to give, right? So when it comes to majority, its opinion would be counted, right? That is why, when I say this thing, opinion would be counted, right? This thing is important because this process is called wisdom of crowd, right? Wisdom of crowd, or the judge example would be a correct thing, that okay, when you have multiple judges, there would be bias, there would be because in specialist model there is a bias, right? So when you use generalized models, the idea of bias is reduced, okay? So what you have to remember out of this, is the bootstrap sampling part. You have to remember the bootstrap sampling part. You have to remember that the features are also randomly decided for each particular model. You have to remember that in case of random forest, each particular model is a decision tree. In case of bagging, all the models is same, right? That is why random forest is a kind of bagging models. There are kind of models where the individual models could be different, and we'll see them later, right? And apart from that, how do we take a decision? We take a decision by the case of majority. What is the advantage of random forest? That they reduce overfitting. And that is why they are highly used in industry, right? Because in industry, what happens, the data are complex. So when the data are complex, what you try to do, you try to increase the complexity of your model. So when you increase the complexity of a model, what will happen, that your model will overfit, and to remove that overfitting, you will come to random forest and other ensemble models, right? So yeah, let's see what all we have covered. So we have covered the idea of weak learner, generalization, what are the category of ensemble models, we have seen random sampling, we have seen random forest. Advantage of random forest, it reduces overfitting, and it's easy to fit as well. And then parameters. So the parameters basically means that what all things that you can change, right? So what is the difference between parameter and hyperparameter, that is also important. So hyperparameters are the one that you can change. Parameters are one that you cannot change, right? So hyperparameter here in this case would be number of trees, right? So when I create a random forest model, I have an option to choose how many trees I have to give. I have the option to choose how I am doing the bootstrap sampling. I have an option to choose how many random features I have, and there are multiple other options. I'll add the link of random forest documentation in the description of this video. You can check that out. So yeah, that is a general idea, guys, of ensemble models. I hope you like this video. This was a part 1 of ensemble models. In the next part, we will understand about boosting model, talking about GBM and XGBoost, another really important class of models that are used in industry, and then we'll talk about stacking in the third part. So yeah, that was all from my side in this video. My name is Shumankit. I work as a machine learning engineer at Worldwide Technology. I also create content, data science. I teach data science. I create content over LinkedIn, Instagram, and YouTube. You can check me out on all these platforms. The link of that will be in the comments. And yeah, meanwhile, just stick to the core concepts of data science, as you know, many tools are coming up in data science, many technologies are coming up in AI. We try to forget the fundamentals and we go towards the specific part. When you go towards the specific part, the risk of that is the tool might be replaced, right? But the fundamental concept will never be replaced, and that is why if you will interview in a good companies, they will ask you these things, right? Because these things will not be replaced. If a person knows the fundamental really well, they can learn anything, right? That is the idea of company when they hire any person, that okay, the fundamental should be really good. Other things could be trained and could be depend on what projects you're working on, right? But the fundamentals are same, right? So I hope you like this video. Let me know in the comments if I missed something, if you want a video on a specific topic, and I'll see you again in the second part of this video. Thank you.